Okay, for this problem, we're given that the expansion of a hollow sphere can be described by the deformation map, where phi of z is equal to lambda as a function of r times the position vector z. We're given that lambda r is a given function of the radial distance r, where r of z is equal to the square root of z dotted with itself. We need to compute the deformation gradient f for the map, and then compute the stretch through the thickness of the sphere in terms of lambda, r, and d lambda dr. So we have our deformation map, lambda r times z, the position vector. We know that r is the square root of z dotted with z, which makes it the distance of the point from the origin. Now part 1, we need to compute the deformation gradient for this map. We know the deformation gradient is f, which is the gradient of phi, or partial derivative of phi I with respect to zj, ei tensor ej. If we plug in our deformation map, lambda of r times z, in index form, we have partial derivative with respect to dj of lambda of r times ei tensor ej. We use the product rule to find that this is equal to lambda times partial derivative of zi with respect to zj plus zi times partial derivative of lambda with respect to zj, ei tensor ej. For the first part, we can rewrite the partial derivative of zi with respect to zj as delta ij, because if those two indices are different, then the derivative will be 0. For example, derivative of z1 with respect to z2 would be 0, but if they're equal, then it would be equal to 1. For the second part, we can use product rule. We use the chain rule to say that it's equal to zi times the derivative of lambda with respect to r times the partial derivative of r with respect to zj, ei tensor ej. We can compute the partial derivative of r with respect to zj. We're going to be using the chain rule for this. We know that r is the square root of zi dotted with zi, and taking the derivative of that square root, we end up with zj over r. We plug that into our gradient, and we come up with lambda times delta ij plus zi times derivative of lambda with respect to r times zj over r, ei tensor ej. And we can simplify this into lambda times delta ij plus lambda prime over r, zi zj, ei tensor ej, where lambda prime represents derivative of lambda with respect to r. And that's part 1.
So for part 2 of this problem, we need to find the stretch through the thickness of the sphere in terms of lambda r and d lambda dr. So for this problem, we're going to call S the stretch. And we know that s squared is equal to fn dotted with fn. N is the unit vector normal to the sphere, which is z, the position vector, divided by its magnitude, which is then z divided by r. In component form, we know that nj is equal to zj divided by r. From part 1, we found that fij is equal to lambda delta ij plus lambda prime 1 over r zi zj. Therefore, f acting on the unit vector n is fij nj ei, which is lambda delta ij plus lambda prime 1 over r zi zj, all multiplied by nj ei. And that simplifies to lambda delta ij plus lambda prime 1 over r zi zj, all multiplied by zj 1 over r ei. And then multiplying that through, we get lambda 1 over r delta ij zj ei plus lambda prime 1 over r squared zi zj zj ei. And that simplifies to lambda over r zi ei, because delta ij multiplied by zj is equal to zi. And then we know also that zj is equal to r squared, so that part cancels out. So for the final part, we can just factor out the zi, ei, and get lambda over r plus lambda prime all multiplied by zi, ei. So f acting on n, the ith component of that is lambda over r plus lambda prime multiplied by zi. S squared, again, is equal to fn dotted with fn. So in component form, that is the ith component of fn multiplied by the ith component of fn. Using what we found earlier, we have lambda over r plus lambda prime zi multiplied by lambda over r plus lambda prime zi. And this is equal to lambda over r plus lambda prime squared zi. And we know that zi is equal to r squared. Therefore, we have s squared equals lambda over r plus lambda prime squared r squared. So s is equal to lambda over r plus lambda prime times r. And then, therefore, if we put it in terms of lambda r and d lambda dr, we have the stretch is equal to lambda plus 1 over r d lambda dr.